So I expect it will probably take us a couple of class periods to talk about things related to our initial discussion of ABAP database interaction. As we have observed previously, a lot of what we will do in ABAP is focused on things related to database tables. Database tables give us persistence from program to program, and so we will be retrieving information from database tables, we'll be modifying information, we will be putting new data into database tables. So there's obviously a lot of different things that our programs need to do in order to interact with databases that are a part of our ABAP infrastructure for our organization. The good news is that compared to other programming languages, ABAP does make this much easier, and so I think that you will enjoy what we have the opportunity to do here. It will give you an opportunity to brush up on your database skills and writing some queries and things of that sort, but probably not anything of a very advanced nature, as typically we're just doing very straightforward selections and other operations akin to that. So let's just talk here in general, and some of this will be a fairly obvious review, but will give us an opportunity to discuss this in the context of ABAP and tie with it some particular terminology. But of course, you know from having taken at least one, if not more, database courses prior to this one, that a database table consists of really two different dimensions. We have the columns or fields, which define what the database table will be storing, and then you have the rows, which are actually the data themselves. We might refer to those as entries, we might refer to those as records, but they are fundamentally the data elements which are stored in the table. Now, if we look in the ABAP dictionary, which becomes key in working with database tables, every database table has a name and then also has other meta information about that database table that is stored in the ABAP dictionary. This would include things like delivery classes. A delivery class controls how a table is transported from one system to the other, and describes in a general way the kind of information that is stored in a table. For example, we have some database tables that are largely storing master data. We have other database tables that are largely storing transaction data. Now, who can give us a quick kind of overview of what the difference is between, what's the difference between master data and transaction data?
Master data is not going to change very often, whereas your transaction data is constant.
Okay, so master data is data that remains relatively stable in the system, whereas transaction data changes, or if you will, occurs with great frequency and with a lot of uniqueness to it. Okay, that's true. Any other characteristics that you can think of about master data versus transaction data? Master data tends to be the data that is exchanged among different business processes and may also describe certain facets of our organization and its operations. So for example, very common examples of master data would be customer data, and by that I mean things like the name of the company, their address, their phone number, their fax number, and a variety of other things that are information about that customer. Similarly, vendor data, information that tells us how to order from a particular vendor, how to pay, other things of that sort. And the third common category that we think of in regards to master data is product data. So a company has a lot of different products or different materials that they work with, and that data, although it certainly can change, it's not like it changes with extreme dynamism. Transaction data, on the other hand, describes data generated as a result of executing business process steps. So a customer calls us on the phone and places an order, and that's going to generate transaction data. Now, if you think about that for a moment in the scenario I just described, a customer calls us, so that's going to leverage customer data, orders products from us, that's going to leverage product data, but there's going to be a lot of unique facets of that particular transaction because it's going to give us a quantity for the materials, it's going to give us delivery dates, it's going to give us a wide variety of other things. Now, of these two, master data and transaction data, which do you think is more abundant in our database? Transaction data, absolutely. Which of these tables do you think tend to be largest? I have a vote for master. Any other votes? Transaction data tables tend to be the largest. Let me show you a very specific example of this. I'm logged into my SAP system here, and I'm actually going to back out for a moment and go to transaction SE11, which we know takes us to the ABAP dictionary. And let me show you one particular table that we may work with later in the semester, table T001. It's a standard SAP table, and I'll elect to display the information. And you can see this is a table that has a lot of fields in it. In fact, it has 81 different fields. So we would describe this perhaps as a fairly wide table, but how much information is actually in this particular table, and what is this information? Well, notice here the short description of the table is this is our company code information. So in our particular system right now, if I click on contents, and I'll just start off here by looking at number of entries, I can see that there are 2 entries in this table, okay? And in fact, if we want to look at it, we certainly can. Here's what's in the table. We have 2 company codes defined in this system. Company code, let's see here, DE00 and US00, representing Global Bike Germany and Global Bike of the US, which is based in Dallas. So this is a table that is very, very wide, but doesn't have very many rows in it at all. On the other hand, it would not at all be unusual to open up a transaction-based database table and see millions of lines there of data. And so the more abundant data for us is the transactional data. And so we have tables with different characteristics. Now, why did I even bring that up? Well, that's going to be defined by the delivery class. When we create a database table, we will describe to the system in a general way the kind of information the table will be storing and how large we expect the table to ultimately grow. And so this is something that we will look at later in our discussion when we start talking about actually creating our own database tables. Maintenance authorization is pretty much exactly what it sounds like. This gives us the ability to define things like whether a table might be read-only or whether maintenance is restricted to a subset of users or a subset of processes. And so the point of this is, in the ABAP dictionary, we have things that provide meta information about the database tables in our ABAP system. As you know from taking a database class in the past, every table will have one or more key fields designated as the primary key. And in fact, unlike standard tables or sorted tables or hash tables, unlike internal tables where we don't necessarily have to concern ourselves with keys, in the context of database tables in the ABAP dictionary, we do see the more typical scenario of needing to designate keys for each of the tables. Now, table fields, as we have observed already in some of your lab work, have data types associated with them. And so some of those data types are loosely defined as data elements. Sometimes, though, they leverage data types which are based on domain data. So just like we were talking about last class period, we might define a domain, we might create a type based on that domain, and we might use that type to describe the data to be stored in a particular field in our database. We also have the opportunity to table fields may be typed without reference to a data element. In this case, the field is said to be direct type, and I showed you this button toggle in a different context previously. So you could go in and say, I want a database table, and I want the type of this field to be character string 3 characters long, and that would be fine. Or you could say, I want this database table particular field to be this particular type, which is we know is based on this particular domain. So you have liberty when defining a table to be as specific or as general as you want. Tables have technical settings which govern how the system should optimize the data storage and access the table. You can, for example, turn buffering on and off for a given table. In more contemporary system where the back-end database is SAP HANA, you could designate whether a table should be row store or column store in its data organization mechanism. And we may talk about that in more detail a little bit later this semester. Two of the key questions here that we will typically define for a table, as I described a moment ago, is what's the expected table size? Are we looking at a table that's going to perhaps have 50 rows in it, or are we looking at a table which is expected to have tens of millions of records in it? We defined this in a way that will allow the ABAP engine to optimize the interaction with the database. Should the table be buffered? Should changes to the table be logged? Usually, buffering is good. It's going to speed up execution. Logging can be a two-edged sword. Turning on logging gives us enhanced data security. But turning on logging carries with it what negative side effect? Performance overhead, absolutely. And so this is something we have to be a little cautious of as far as how we make the design decision. So this is some fundamental concepts related to database tables. Let's get a little bit more specific. If we go into the ABAP data dictionary and we create a definition for a table, which we won't do now, but we will do shortly enough, what we are actually creating at that point is something called a transparent table, which means that it exists in the context of the definition in the data dictionary, but it doesn't actually exist in the underlying database. How do I get the table to exist in the underlying database? That happens when I activate my transparent table. So the process here, you would go into the ABAP dictionary, you would describe the fields, you would set the data types, you would set all of the different characteristics we were talking about on the last slide. And then once you had that definition done, to actually create it, that happens by way of the activation process. Now, it is critically important to realize, and we'll refer back to this a few times, remember, we have a three-tiered architecture here. We have at one end, we have the client, or we have the end user, or we have the presentation layer. And so that's really not a factor in what we're talking about here. But we have the application server, which is where ABAP and the SAP engine exist. And then we have the database server. So what we are describing here is a situation where you go into the ABAP dictionary on the application server, and then when you activate what it is that you have done, that results in this actually being created on the database server. But a key facet of this is the fact that ABAP is database agnostic, which means that this database server could be, although you wouldn't typically see this in a corporate environment, it could be MySQL, It could be IBM DB2. It could be Microsoft SQL Server. It could be an Oracle database server. It could be a wide variety of different commercial products. But the key is, it doesn't matter what this actually is. We always do things the exact same way on the application server. And it's the role of the application server then to come in and translate what we have done to the appropriate specification for the back-end database. So one of the things that we know is that if I create a database table and give it a name in the application server, in the ABAP dictionary, that the underlying database system will create a table with that same name. So we do have that one-to-one matchup. But where this gets really, really interesting is in the field definitions. The field types in the database-specific table are converted to whatever the appropriate data type definition is for that particular database. So if we go in and we use a domain to limit values, and we apply a very specific data type to one of our fields. Let's say, for example, we create a data type called s_cust_num. And it just describes a standard customer number. And we've defined that data type. Well, does that mean if we were to look on our Oracle database server that we would see that as the data type of that field? The answer is no. That's not a data type that Oracle will understand. So what the ABAP engine is going to do is it's going to translate it into whatever the appropriate database type would be for the database server as a part of the table creation process. And then the ABAP system is going to work on maintaining the integrity of the information beyond the level that the database server may be able to accomplish. In addition, underlying elements of the table, such as field order, etc., may be changed as necessary. And in fact, SAP does some really, really, really weird things in their databases. You will see tables, and you don't see an abundance of this, that are called cluster tables. And a cluster table may have a huge number of fields. It may have, let's just say for sake of argument, 350 fields. Well, if we were to try to create a database table with 350 fields, and let's just say an Oracle database, that could be very, very problematic. And in fact, some databases might not even support tables of certain dimensions we might desire to do. So what ABAP, what SAP does to work around that in a cluster table, is you have 350 logical fields, but the database table that's created in the database might only have 35 fields. And every one of those fields actually stores 10 pieces of information. But that's all transparent to you. That happens because what you define in the application server in the ABAP dictionary is going to be translated automatically to what it needs to be for the sake of the database server, and you don't have to worry at all about the underlying implementation on the database level. The transparent table in the ABAP dictionary is the database independent representation of the underlying table. And it's the definition that we use in ABAP programming. So, you might create a table and specify the fields in a certain order, and perhaps in order to optimize working with the data in that table, the ABAP data dictionary might, when it creates the table in the underlying database, it might reorder your fields. You don't have to worry about that. That's all going to be handled in a manner that is totally abstracted from you because you just deal with things based on the way they're defined in the ABAP dictionary. Now, what this means is, if we have done everything the way we should, and we'll talk about later on some things that we could do that might come back to bite us in this instance, we could take an Oracle database server and as a company decide to move to an IBM DB2 server and have the transition be totally seamless as far as our ABAP programs. We don't have to rewrite them. As long as we follow what are considered best practices in SAP database-related programming. So we have this idea that our definitions of our database tables, all of the metadata, all of the field definitions, all of the descriptions, we find those in the ABAP dictionary, which if you think about it, that means that all of our interactions are based on things that happen on the application server level. Then the application server, as needed, will go out and deal with the database server, translating things as they need to be translated. If you will, it would be like we could talk to the application server in English, but the database server might be French, and so it has to translate that into French. So it takes our English, it translates it into French, sends it to the database server responds in French, and it translates it back into English and then hands it back to our program. Now, I did that analogy based on languages, which I'm not saying it does language translation, but I'm saying it translates our syntax and the information that we put into our program to the syntax needed by the underlying database. As a result of this, we do not interact with the database server directly. When you create database tables, you cannot create database tables programmatically. The way we create database tables is in the ABAP dictionary. When we want to manipulate database tables, we do not log into, let's say, an administrator's console or an SQL console on the database server. We do all of our interaction with the database through the application server. What that does for us is gives us something that is very, very important in a business environment. It gives us what is called a sealed database. And the idea here would be, you see semi-trucks driving down the road, and a lot of times they have really significant locks on them. But then in addition to locks, sometimes they have these really look fairly flimsy metal pieces that are put over the lock that is there just to signify the fact that this was sealed up when it left wherever the origin was, and when it gets to the destination, someone's going to inspect that and make sure that that seal wasn't broken or hasn't been changed or replaced. That seal is just there to certify that no one has opened up the back of the truck and gone in, so we have confidence that it's the same stuff that left the point of origin. One of the things that we as organizations have to be careful about in the current environment is we have laws like Sarbanes-Oxley that require an organization to certify that their financial records are correct and kept according to appropriate generally accepted accounting principles and other things of that sort. So what does that mean? That means that just like the truck, which has a seal put on it that says nobody has gone in here, all of our database interaction is managed by the application server integrating with the database server. And that will result in a seal being put on our database that you can run various transactions to see if that seal is unbroken. If we ever go in through the database server directly and start manipulating tables, we break the database seal. And at that point, all bets are off. At that point, SAP will no longer officially support our organization. If we're a publicly traded company, when our auditors come in, one of the first things they will do is check the seal on the database. If they see that it is broken, they will go on a massive fraud hunt, because this is a sign that our organization is not handling information correctly. So the big point of all this is, even though we have a database server, and even though we might know on some level, well, that's an IBM database server, an Oracle database server, we should get in the habit of treating that like a black box. And we should confine all of our interaction to the database server to things coming from the application server. Now, as a point of fact, does that mean we can't do anything with the database server? No. You can, for example, back it up. You can do performance tuning, but we can't do anything that would in any way change, manipulate, or otherwise affect the actual data itself. Questions about any of this?
When we first started, we had to enter an activation code to be able to program inside of ABAP. And I assume that that's so, one, you can't mess with any of the internal data at all. And two, if you didn't have that, can you get into SE11 and even display or create anything? The security to make sure that people that don't know what they're doing can't touch it.
That's a really, the part about getting into SE11 is one that I don't know that I can answer for you right off the top of my head, but I do know how we could check, which is we have a lot of accounts that aren't in use this semester. I don't remember, anybody remember off the top of their head what the default password was when we first got started? That I sent you the email for. Anybody happen to remember that? Oh, that's good. Now this is interesting. I'm trying to log into our server here and I'm not getting a connection, which is unrelated to that. I do have internet. So in a second here, we will try to answer that as far as the getting into SE11. I do know that as far as being able to do any kind of development or creating things, you're going to have a developer key for that. But as far as actually just being able to look at something, I'm not really sure if a normal user account can do that. So in a second, we'll see if we can get back into the SAP system, which at the moment we're locked out of. So we'll come back to looking at that question. So what I was just describing to you is illustrated with this diagram right here. We have the presentation layer. This is the end user side of things, which as far as we're concerned here is not an element in our discussion. What we are more interested in is the relationship between the application layer and the database layer. And so what's going to happen is as ABAP programs begin to exist and to do their work, the application layer will spawn work processes. And those work processes will connect as needed to work processes on the database layer. And they will interact with one another for the sake of passing information back and forth. You'll notice that both the application layer and the database layer are buffered. That's to give us performance speed. Generally speaking, a buffered read from the database server will happen at a rate of 0.1 milliseconds per database record. So the buffer does give us rather good overall performance, but in those instances where we're retrieving information not from the buffer but from the underlying database disks, on average that's going to drop our access speed to 10 milliseconds per record. So the buffer is there to allow us to speed up operations. The underlying database, the size of that is going to depend rather significantly on the size of our organization. I would say that you will find this typically for most organizations of any size to be between 4 and 10 terabytes of size. So we're looking at a fairly sizable database here. And so the idea is there's a lot of information we're going to be pulling out of the database with great frequency. Let's say, for example, information about our materials. We sell a lot of products to customers really on a continuous basis. If every time we had to look up product information, we had to go to the database tables, our system would perform very slowly. So we could designate material-related tables to be buffered. The size of the buffer depends on the performance aspects of our database server. And we can set it to be the smallest database buffer you can define is 500 megabytes, but you can create ones much larger than that if you have the hardware to support it. And so this is the overall, what's called the architecture, the WAS, which is the workflow architecture for the overall interaction between the systems.
So is the only downside to the buffer the extra storage space needed? I mean, or do you have any other ones?
No, I mean, and it's not so much I mean, yes, it is storage space, but all of this is a function of money. You know, a company, you know, you could say, well, couldn't the company get better performance by not using disks and instead moving to flash memory? And absolutely, the answer is yes, and a lot of companies do that, but 10 terabytes of flash data is not cheap, you know. Now, as time goes by, things get cheaper and faster and so on, which is part of the whole idea behind SAP HANA, where we put the entire database in active RAM memory. And so you get a significant performance hit or performance improvement from that, but you've got to be able to afford, let's just say, 4 terabytes of RAM memory, which some companies can afford, some companies cannot. You know, these systems will run in the millions of dollars. So the more money you have, it's kind of like a race car. You know, the better engine you can put in here, the faster, better components you can put, the better your performance is going to be. But sometimes you get into a situation where you have to question, is it worth the extra money for this little bit of performance improvement? And so companies all the time are making assessments as to hardware opportunities and other things that might allow them to improve their overall performance here. Good question. Other questions? All right, so if the underlying database can be one of any number of different flavors of databases, but we need to write our code in a way that is database agnostic, we need to decide on a syntax that gives us support for that universality. And so what we actually use is something called OpenSQL. Now, OpenSQL is an industry standard language. You can go out and actually purchase books on OpenSQL. But the syntax of OpenSQL will be similar to, but subtly different from, let's say, Oracle SQL, or IBM DB2 SQL, or MySQL SQL. And perhaps you've already seen in some of your work with databases that maybe if you move from one database platform to the other, the code you write is mostly similar, but there are some things that might be different. Well, the whole idea behind OpenSQL is we don't run into that. We write our code using OpenSQL, and then the ABAP engine, the ABAP work process, will translate it into whatever the appropriate database-specific SQL is that needs to work. Now, I tell you this next fact just to give you completeness in your knowledge. It is possible to access the database using that database's system in native SQL. But the code that you create then is database specific and less transportable. So the idea is, I'm doing something in ABAP, and I know that I have an Oracle database server. As we will discover, there are certain things that you could do in an Oracle specific SQL statement that is not supported in OpenSQL. There are some things that OpenSQL just doesn't support because they're not universally supported by all the different database vendors. So OpenSQL, you could see it as kind of a universal language that we can easily translate into all of the other major versions that are out there. But every vendor is going to have their own specific syntax extensions that work specifically with their system. So what I'm telling you is, you could write code in your ABAP program and tag it in a way that you tell ABAP, don't translate this, just send it directly to the database exactly as I have written it, and you have written it in a way that you know your Oracle database server will understand. You have just shot yourself in the foot in a major way. Because what happens now if in 5 years, now this isn't likely to happen, but let's say Oracle goes out of business, or Otherwise, your company decides to move away from Oracle as a database vendor and move to another company. You're going to have to go back, and first of all, you're going to have to find all this code, which that's going to be fun, and then you're going to have to rewrite all this code. So it's kind of one of those things. It might, in the very, very short run, seem like a good idea, but in the long run, it is a very, very, very bad idea. And as a specific example of this, there are several companies I'm familiar with that are going through the process now of converting from Oracle or IBM DB2 to SAP HANA. And the problem is, or the scenario is, if they had written all their code in OpenSQL, this would be like easy. You know, you could do it in a couple of weeks. But what a lot of these companies have done is use things like what's called code hinting and other things in their interaction to take advantage of performance improvements. And now they got to go back and find and rewrite all of that. And they are, you know, kind of kicking themselves from, you know, past history because they have created a much larger headache for themselves and a much more expensive proposition than if they hadn't done this. So do be aware you can write native SQL, but it's pretty stupid to actually do so in a real-world environment. As I have been saying, the idea here is open SQL statements mirror those of traditional SQL, but there are subtle differences and refinements. You know, you may not have all of the options that you would have in a particular database vendor's, let's say, select statement. Or the Oracle database select statement might support a particular syntax in their where clause that's different in OpenSQL. So you're not going to see anything in our discussion of OpenSQL, I trust, that will look very different from things that you have seen. But you are going to have to get used to the fact that the syntax is subtly different. And the reason why it's different is to give us this database agnosticism. Okay? Questions? Now, you probably could have figured this first point out by inference from things that I have said already. OpenSQL only contains DML statements, data manipulation language statements. It does not contain any data definition language statements, any DDL statements, because those are done using the ABAP dictionary. Can anybody tell us what would be an example of a DDL statement? Create table. Can't create a table programmatically. Don't even have OpenSQL syntax to do that because you create table in the ABAP dictionary. Similarly, can't drop a table. Doesn't exist. You don't even have those kinds of statements. The only statements you have in OpenSQL are select, update, insert, delete, and other less commonly used ones as well. But for the sake of what we will do, those are going to be the four that we will focus on. So we can delete records from a table programmatically, but we can't drop the entire table. We can insert, we can update records, we can pull records out of the table, but we can't actually create tables and other things like that in the syntax of our program because all that gets done in the ABAP dictionary. All right. Having laid the foundation, now let's move into some specifics. Every time we interact with the database, there are going to be two SY fields that are going to be populated with information. SY-SUBRC will be set to 0 if what we just attempted to do was able to be done successfully. So if we ran an update and we wanted to know if the update was successful, we could check SY-SUBRC, and if it's set to 0, thumbs up, we know that was good. So one of the things you want to put a big star next to in your notes and or brain is the idea that when we start interacting with the database, every time we ask the database server to do something, we're going to query it to see if in fact it was done correctly. Now, why do we need to do that? Why do I need to check this?
Because if you have to have that data in the database and it fails, you didn't check it, then the rest of your program's not good.
Okay, sure. The idea is I can write a program in my program an insert statement. I can say insert this into this database table. And if it's successful, this is going to be set to 0. If it's not successful, it's going to be set to something else. But if I don't check, the database server could have been offline. And my insert statement resulted in absolutely nothing being done, and I won't know about that error condition. And it won't in any way change the flow of my program. If I don't take the time to check it, I might put a message on the screen that says, congratulations, database updated, and it really wasn't. So anytime I ask the database to do something, basically I have to say, do this, and then I have to say, okay, did you do that correctly? And the way I check to see whether it did it correctly, one way is by checking sy-subrc. Now, it is universal that 0 means success. If it is set to another number, the meaning of that number will depend on what it was that I just asked it to do. So an error message code of 4 will be different for a select statement versus an insert statement. And so as we start talking about the various statements that we will develop here, we'll talk about what values you might see. So we want to build into our brain this idea that we don't ever assume that something we asked the database to do was in fact correctly done. We have to check this. The other SY-related data object we can test is sy-db count. sy-db count is set to the number of records affected by the last operation. And you can imagine that depending upon what I'm doing in my program, sometimes it might make sense for me to check sy-db count. Sometimes it might make sense for me to check sy-subrc. If I say select, and then whatever it is I want it to select, and I execute that statement, and I want to know before I go into the rest of my program whether or not I got back any data. Well, I could check sy-subrc, and that would just tell me, yes, your select was correctly executed. But technically speaking, it doesn't tell me whether I got back any data, because you could write a select statement that's perfectly syntactically valid, but returns nothing. So it might make more sense for me to check sy-db count. Similarly, if I have an insert statement, well, after the insert, I could check sy-subrc to see if it's set to 0, or I could check sy-db count. I would expect to see it set to 1 for an insert statement. So depending on what I'm doing and the overall logic of my interaction with the database, I may want to check one of these two. I may wind up checking both of these, but this is how I am going to know whether I have success or not. And this will be a key thing for you to incorporate into your programming. Now, the fact is, you should write all your ABAP programs such that if the database server is offline, your program still behaves reasonably. The hard part of that is there's no way for me to simulate the database server going offline. So there's going to be a lot of times where you're going to have to write in error checking code, and you may never actually be able to see the error situation in your testing, but you still want to code in that manner for the instance where there might be a database-related problem. I think I've taught this course now for I don't know how many years, but we did one semester have a time where the database server went offline. And it was kind of nice because all the students, they couldn't totally finish their programs, but at least they could see that their error handling worked correctly. But that's only happened that one period for like 2 or 3 days, you know. So other than that, we have to write the code and then just step through it mentally to make sure that we have appropriate tests in place. All right, so we're going to start with a very obvious place, the select statement. The select statement consists of 4 parts, some of which could be optional. We have the keyword select. We can have the keyword single. And then after select or select single, either a list of fields or, of course, our good friend that we want to avoid using, select star or select single star. And of course, as you know, this determines the fields that are going to be retrieved. The idea behind select single is it is going to only retrieve the first match it finds, and then it's going to stop. Why might that be useful and a good thing for us to incorporate into our coding in certain instances other than just a normal select? What's that? It could have something to do with that, perhaps.
It won't continue to search the database if we're sure that there's only one match.
Okay, very good. So remember, some of our database tables could have millions of records in them. Let's assume that we know that due to the logic of what we're asking the database that there should be only one match. Let's say, for example, we want to retrieve information about our customers. Well, we know that a given customer is unique. Every customer is unique, but we have millions of customers in our database table. If I use a standard select, if it finds a match in the 10th record, it's still going to keep looking at all the other records to see if they match up too. But if I know there's only going to be one match, select single tells it, hey, find the one guy or the one gal, the one record that matches, and then you can stop work. So anytime that I know that I'm only actually going to be pulling out one thing, or sometimes I just want to see if data exists, and so I need to find a record that matches this, but I don't need all the records that matches this, select single can give us a significant performance improvement. So our select statement will start with the keyword select. It will either contain or not contain the word single. It will contain a list of fields or a star. Next part, from, and then the name of a database table. Not much to say here. There's really no switches or no options. You're just going to put from in the name of the database table you want this particular query to be accessed against. But where do we want the results to be put? That's the into clause. And the idea here is I can put the result into an internal table, in which case it will say into table and then list the name of the internal table. Or if I use select single, I could actually be storing this in a single data object that represents a structure. And so I could say into corresponding fields of, and then I could list a structure there. Or I could say into corresponding fields of table, which is always good to do and consistent with what we talked about when we were talking about our use of filling internal tables. So the into clause specifies the data object where the result will be stored, and it's typically going to be a structure if I did a select single or an internal table. The key is here, if it is going into a table, you got to be careful to use that keyword table. It's very, very easy to write select star from database table into internal table. And when you do that, you've just caused a problem because you're going to have to put into table there to have it operate the way that it needs to operate. As we have observed previously, the results will be loaded into the destination structure or table based on left to right field match. So whatever I listed up here, if I listed the fields, is going to be the order that it's going to expect the internal table or the structure to match up to, but I don't want to rely on that coincidental correctness. That's why corresponding fields of is always a recommended part of that statement. So we have four parts: the select part, the from part, the into part. Oh, If I'm going to retrieve into individual data objects, I can do this. I could, for example, say select first name from customer table into, and then I could list in parentheses just a normal data object like fname, because I know the result of that particular selection is just going to be a single, let's say, character string in this instance. Or if for whatever reason I didn't want to actually create a structure, I could say select first name, last name, middle initial from database table into, and then in parentheses put fname, comma, lname, comma, middle name, where those are all data objects that have been defined in the context of my program. So the most common thing here I would expect would be retrieving into an internal table. The second most common thing would be retrieving into a structure. And the distant third that we will use very, very rarely is retrieving into individual data objects. The where clause. We'll say more about this on another slide, but this just simply specifies which rows are retrieved, where we're using combinations of field equals something or some other kind of Boolean representation of which elements are to be selected. Now, when I go through these statements and talk about sy-su-brc values, I'm not necessarily going to give you an exhaustive list of all the different numbers. I'm going to give you the ones that are most commonly going to result. sy-su-brc, if it is set to 0, that means your select statement was successful. If you get back an sy-su-brc of 4, then you know that no data was found. Now, there's an important distinction here. Your query could have been run correctly and you got no data back, or your query might not have been run and so you got no data back. So knowing why there was nothing put into whatever you specified in your into clause is you're going to have confidence about that based on testing the value of sy-su-brc. So here's some example code. Data itab, type table of spfly. That's a data type that is in the database that is a structure capable of holding the fields that you see listed there. Data WA, like line of itab. Select Mont, Carrot, Conid, city from, city to. So I notice I'm just listing the fields with spaces between them from the name of my database table into corresponding fields of table and then my internal table. And then from here, we see code that is similar to what we have written before in working with internal tables. Loop add itable into WA, where we're writing out the things that are in the work area. Questions? All right, let's do one more slide, and then we will call it to a close. This is the first place where, depending upon what database tools you have been using, may be a place where you see your first significant difference in syntax. With the where clause, you can test for equality using either the equal symbol or EQ text. So we could say where last name EQ Smith or last name = Smith. You can use wild patterns to match a pattern with like. So you could say where last name like, and then you see the example there. An underscore matches a single character, where a % symbol matches a character string of any length. So how would you describe what I am asking to be retrieved by the query at the end of the slide here?
Like Tony, Tina, Tommy.
Close, but not exactly right. You missed the underscore. something where the second letter is a T, okay? So you can put together wildcard sequences like this in the context of your where statements if you're not matching based on strict equality, okay? Well, this is a good place for us to stop, but I do want to take questions.
Oh, yeah. I was just gonna ask, does ABAP get confused if I were to put 4 or 5 of those underscores together? It'll just treat it as normally?
Yes, it can handle that. That's not a problem.
When exactly do you set to your sub SUBRC? Like, you're doing that through a conditional statement, I assume, not going into a database and seeing that set to 0.
Right, you're just doing if sy-subrc equals, or you could put not equals 0,
Sure.
then you would have some error handling code there.
In the previous code example, would that be before the loop or?
Yes,
Okay.
yes, because you wouldn't want to bother going into the loop if you have nothing to output.
Gotcha. Yeah.
All right. Other questions? All right, well, this is where we will stop for today. Have a good rest of the day, everyone.